Math 2414, Differential Equations, Video 1. For full disclosure, I'm recording in a different room. I think the acoustics are a little bit different, and there seems to be some air vents blowing near the board, so I hope the audio for this video is acceptable. All right, so we're going to start with some basic definitions. It's a good place to start. And full disclosure, if you happen to be watching this video and you're not currently in my Math 2414 class, this is a Calculus 2 class, and this is a section about differential equations. If you're taking a differential equations class and watching this video hoping to glean some sort of expertise for your course, you'll probably be disappointed because this is just differential equations at an introductory level in Calculus 2. All right, that being said, we're going to start with some basic definitions, and I've got three to go over really quickly. A differential equation is simply an equation relating an unknown function, y equals f of x, and its derivatives. I've got an example here where we have the second derivative of y plus the 2 times the first derivative of y plus y itself is equal to 8e to the negative 3x. There are many variations of differential equations. This is actually a very simple and straightforward one in the realm of differential equations. But in general, it is just an equation relating a function and its derivatives. The order of a differential equation is the order of the highest derivative in the equation. So in other words, you look at the derivatives and see which one is the highest order. Well, this being a second derivative, its order is 2. This being a first derivative, its order is 1. This not being a derivative, its order is technically 0. And since the highest order derivative is here, we would say that the order of this dE is 2. And in case you haven't picked up on it, I'm abbreviating the phrase differential equations with dE, very standard abbreviation. The order of this dE is 2. Now, for my Calculus 2 class in this introduction to differential equations, we're only going to be dealing with first order differential equations, meaning that the highest order derivative will just be y prime. This is a pretty intuitive definition. A solution, y equals f of x, of a differential equation is a function whose derivatives satisfy the differential equation. It's the same thing as a numerical solution to a polynomial equation or something like that. You have a number that makes the equation true, but here we're looking for a function that makes the equation true. I'm going to tell you the solution to this differential equation without worrying about where it came from. Well, we're going to verify that y equals 2e to the negative 3x is a solution to this differential equation. Now, how do we check that? Well, we would substitute 2e to the negative 3x for y, calculate its derivative and substitute it for y prime, and calculate the second derivative and substitute it for y double prime. So to do this, let's find our derivatives. The E rule says leave it alone. The chain rule says times the derivative of the exponent. So the derivative of the exponent is negative 3. Negative 3 times 2 is negative 6. And so our first derivative is negative 6e to the negative 3x. And for the second derivative, we just take the derivative of the first derivative, which again invokes the chain rule, and is going to multiply by another negative 3. Negative 3 times negative 6 is 18. So there's our function, first derivative and second derivative, and now we just have to substitute them back into the original differential equation to make sure that it makes it true. We'll do it up here. Our second derivative is 18e to the negative 3x plus 2 times the first derivative, which is negative 6e to the negative 3x, plus our original function, which was 2e to the negative 3x. But it doesn't take too long to see that this is a solution. The only thing we have to do before we combine all three of these like terms is to multiply the 2 times negative 6 e to the negative 3x to get negative 12 e to the negative 3x. And now all three of these terms are like terms, and we just simply add their coefficients. 18 minus 12 is 6, 6 plus 2 is 8. And so their sum is indeed 8e to the negative 3x. The remainder of these videos will be about finding solutions to a very particular type of differential equation, showing what the graphs of some of the solutions look like, doing an application involving mixtures, and discussing something called direction fields or slope fields.